Yes, a brushless mechanical alternator exists. It's a type of alternator designed to eliminate the need for brushes to transfer current between the rotor and the stator. This is achieved by using induction to generate current within the stator. The advantages of brushless mechanical alternators over traditional alternators are numerous. Firstly, they offer improved efficiency. The absence of brushes reduces friction and electrical losses, resulting in a more efficient energy conversion process. Secondly, maintenance requirements are significantly reduced. Brushes are subject to wear and tear and require periodic replacement. Eliminating them translates to less downtime and low maintenance costs. Thirdly, brushless alternators are generally more reliable. The elimination of brush wear and associated issues contributes to a longer lifespan and increased operational reliability. The fundamental principle behind a brushless mechanical alternator remains the same as a traditional alternator. A magnetic field is established within the rotor. As the rotor rotates, this magnetic field induces a current flow in the stator windings. However, the key difference lies in how the magnetic field is generated. In a traditional alternator, brushes are used to supply current to the rotor windings, creating an electromagnetic field. In a brushless alternator, permanent magnets are employed to generate the magnetic field. The stator in a brushless alternator is typically constructed from copper windings. These windings are strategically positioned to interact with the rotating magnetic field. The rotor, on the other hand, is often made of iron, providing a structural support for the permanent magnets. The permanent magnets are securely mounted onto the rotor's surface. As the rotor spins, the magnets rotate along with it, creating a rotating magnetic field. This rotating field is what induces the current flow within the stator windings. The output from a brushless alternator is inherently alternating current or AC. However, many devices require direct current or DC to operate. Therefore, the AC output must undergo a process called rectification to convert it into DC. This is typically achieved using diodes or other electronic components. Brushless mechanical alternators find applications in a diverse range of industries. In the automotive sector, they are used in vehicles as part of the charging system. In marine applications, they provide power for boats and ships. Industrial settings utilize them in generators and various other equipment. Their suitability stems from their reliability, efficiency, and reduced maintenance needs, making them ideal for critical applications where consistent performance is paramount. A more detailed explanation of the components and operation is necessary to understand the technology better. Firstly, let's consider the rotor. As mentioned earlier, the rotor is typically made of iron, serving as a strong foundation for the permanent magnets. The design and material selection of the rotor are critical for withstanding the centrifugal forces generated during high-speed rotation. Secondly, the permanent magnets are typically made from rare earth materials like neodymium or samarium cobalt. These materials possess exceptional magnetic strength, allowing for a compact and efficient design. The magnets are carefully arranged in the rotor to create a specific magnetic field pattern. Thirdly, the stator is composed of numerous copper windings embedded within a laminated iron core. The laminated core helps to reduce eddy current losses, further improving efficiency. The windings are connected in a specific configuration to optimize the output voltage and current characteristics. The interaction between the rotating magnetic field of the rotor and the stator windings is governed by Faraday's law of electromagnetic induction. This law states that a changing magnetic field induces a voltage in a conductor. The magnitude of the induced voltage is proportional to the rate of change of the magnetic flux and the number of turns in the winding. The frequency of the AC output is directly proportional to the rotational speed of the rotor. The faster the rotor spins, the higher the frequency. The voltage and current output of the alternator can be controlled by varying the strength of the magnetic field and the number of turns in the stator windings. Brushless alternators offer several advantages over traditional brushed alternators. One key advantage is the elimination of brush wear. In brushed alternators, the brushes constantly rub against the slip rings, leading to wear and eventual failure. This requires periodic replacement of the brushes, which can be a costly and time-consuming process. Brushless alternators eliminate this maintenance requirement, resulting in lower operating costs and increased uptime. Another advantage is improved reliability. The absence of brushes reduces the risk of sparking and arcing, which can cause electrical noise and interference. Brushless alternators are also less susceptible to contamination from dust and debris, further enhancing their reliability. In addition, brushless alternators typically offer higher efficiency than brushed alternators. The elimination of friction between the brushes and slip rings reduces mechanical losses, resulting in a more efficient energy conversion process. This can translate to significant fuel savings in applications where the alternator is driven by an engine. Brushless alternators are used in a wide range of applications, including automotive, marine, aerospace, and industrial. In automotive applications, they are used to charge the battery and power the electrical system. In marine applications, they are used to power navigation equipment, lighting, and other electrical load. In aerospace applications, they are used to power aircraft systems such as lighting, avionics, and environmental control systems. In industrial applications, they are used to power generators, motors, and other electrical equipment. The design and construction of brushless alternators can vary depending on the specific application requirements. However, the basic principles of operation remain the same. The rotor is typically driven by an external power source such as an engine or a motor. As the rotor spins, the permanent magnets create a rotating magnetic field that induces current in the stator windings. The output voltage and current are regulated by controlling the strength of the magnetic field and the speed of the rotor. Brushless alternators are a mature technology, and they have been used for many years in a variety of applications. However, ongoing research and development efforts have focused on improving their performance, reducing their cost, and expanding their range of applications. Some of the key areas of research include improving the efficiency of the magnets, optimizing the design of the stator windings, and developing new control strategies. The increasing demand for energy efficiency and reliability is driving the adoption of brushless alternators in a wider range of applications. As the technology continues to evolve, brushless alternators are expected to play an increasingly important role in the future of power generation and distribution. Further points of interest include the field winding, which in some designs is still present but implemented in a rotating field exciter to provide the magnetic field. This exciter does not require brushes as it uses rotating diodes or other means to rectify the current. The main magnetic field is produced by the exciter's output, which is then fed to the main rotor. The absence of brushes in the main rotor circuit is what classifies the alternator as brushless. The armature is connected to the load, and the field winding is responsible for creating the magnetic field. In a brushless alternator, the field winding is located on the rotor, and the current is supplied to it through a rotating rectifier. The rotating rectifier converts the AC voltage from the exciter into DC voltage, which is then used to power the field winding. The rotating rectifier consists of diodes or thyristors mounted on the rotor. These components are subjected to high centrifugal forces, so they must be carefully selected and mounted to ensure reliable operation. Brushless alternators are also used in wind turbines. In this application, the alternator is directly driven by the turbine blades. The alternator generates AC power, which is then converted to DC power by a rectifier. The DC power is then used to charge batteries or to power an inverter, which converts the DC power back to AC power for use in the grid. Brushless alternators offer several advantages over traditional alternators in wind turbine applications. Firstly, they are more reliable. The absence of brushes eliminates the risk of brush wear and sparking. Secondly, they are more efficient. The elimination of brush friction reduces mechanical losses, resulting in a more efficient energy conversion process. Thirdly, they are smaller and lighter. The absence of brushes allows for a more compact design. In summary, brushless mechanical alternators represent a significant advancement in alternator technology. Their efficiency, reliability, and reduced maintenance requirements make them a compelling choice for a wide range of applications. As technology continues to evolve, it is anticipated that brushless alternators will play an increasingly important role in shaping the future of power generation and distribution. Brushless alternators are also less susceptible to radio frequency interference or RFI due to the absence of sparking brushes. This makes them suitable for use in sensitive electronic equipment and applications where RFI is a concern. To control the output voltage of a brushless alternator, an automatic voltage regulator or AVR is used. The AVR senses the output voltage and adjusts the field current to maintain a constant voltage level. The AVR is typically a solid-state device that uses feedback control to regulate the field current. Brushless alternators can also be used in parallel operation. This means that two or more alternators are connected together to supply power to a common load. Parallel operation can increase the overall power output and improve the reliability of the system. To operate alternators in parallel, they must be synchronized. Synchronization involves adjusting the voltage, frequency, and phase angle of the alternators so that they are all operating at the same point. A synchronizing panel is typically used to monitor and control the synchronization process. Brushless alternators are available in a wide range of sizes and power ratings. Small alternators are used in portable generators and other small applications. Large alternators are used in power plants and other large-scale applications. The selection of the appropriate alternator for a given application depends on a variety of factors, including the power requirements, the operating environment, and the cost. Here are some additional points to consider. Firstly, cooling is critical for brushless alternators. The heat generated by the windings must be dissipated to prevent overheating and damage. Brushless alternators typically use air cooling or liquid cooling. Air-cooled alternators use a fan to circulate air around the windings. Liquid-cooled alternators use a coolant, such as water or oil, to absorb heat from the windings. Secondly, vibration can be a concern in brushless alternators. Vibration can cause fatigue and failure of the components. Brushless alternators are typically designed to minimize vibration. This can be achieved by using a balanced rotor and by mounting the alternator on vibration isolators. Thirdly, insulation is important for brushless alternators. The windings must be insulated to prevent short circuits. Brushless alternators typically use a high-quality insulation material such as epoxy resin or varnish. Fourthly, maintenance is still required for brushless alternators, although it is less frequent than for brushed alternators. The bearings should be lubricated periodically, and the windings should be inspected for damage. Fifthly, testing is important to ensure that the alternator is operating properly. Brushless alternators should be tested regularly to verify that the voltage, current, and frequency are within the specified limit. Testing can also help to identify potential problems before they lead to failure. Finally, standards apply to brushless alternators. Brushless alternators must meet certain standards to ensure that they are safe and reliable. These standards are typically set by organizations such as the International Electrotechnical Commission or IEC and the National Electrical Manufacturers Association or NEMA. Consider also the impact of altitude. The altitude at which an alternator is operated can affect its performance. At higher altitudes, the air is less dense, which can reduce the cooling capacity of the alternator. Alternators that are operated at high altitudes may need to be deaerated to prevent overheating. Consider also the effects of humidity. Humidity can also affect the performance of brushless alternators. High humidity can cause condensation to form on the windings, which can lead to corrosion and insulation breakdown. Alternators that are operated in humid environments may need to be specially designed to prevent these problems. Consider also the impact of dust and dirt. Dust and dirt can accumulate on the windings of brushless alternators, which can reduce their cooling capacity and lead to overheating. Alternators that are operated in dusty or dirty environments may need to be cleaned regularly. Finally, consider surge protection. Surge protection is important for brushless alternators. Surges can damage the windings and other components of the alternator. Surge protection devices, such as surge arresters, can be used to protect the alternator from surges. Brushless alternators are a complex and sophisticated technology. However, by understanding the basic principles of operation and the various factors that can affect their performance, it is possible to select, install, and maintain them properly. This ensures reliable and efficient operation. Brushless alternators have become the standard for many applications due to their inherent advantages in terms of maintenance, reliability, and efficiency. Their design allows for a more robust and long-lasting machine with fewer moving parts that are subject to wear. The technology continues to advance with improved materials, designs, and control systems, making them even more efficient and reliable. The future of brushless alternator technology includes further advancements in materials, such as high-temperature superconductors and nanomaterials. These materials could lead to smaller, lighter, and more efficient alternators. Advances in power electronics are also playing a role in improving the performance of brushless alternators. New control algorithms and power devices can optimize the efficiency and reliability of the system. Furthermore, the integration of digital technologies and Internet of Things or IoT capabilities is enabling predictive maintenance and remote monitoring of brushless alternators, further enhancing their reliability and reducing downtime. The constant push for higher efficiency, lower cost, and greater reliability will continue to drive innovation in brushless alternator technology, ensuring their continued importance in a wide range of applications. Brushless alternators have a wide variety of uses, including electric vehicles. Electric vehicles rely on efficient and reliable electric motors and generators to provide propulsion and regenerative braking. Brushless alternators can be used in electric vehicles as part of the regenerative braking system. When the vehicle brakes, the motor acts as a generator, converting kinetic energy into electrical energy. This electrical energy can then be used to charge the battery, extending the range of the vehicle. Another use of brushless alternators are in hybrid vehicles. Hybrid vehicles combine an internal combustion engine with an electric motor and generator. Brushless alternators can be used in hybrid vehicles as part of the hybrid powertrain. The alternator can be used to charge the battery, provide supplemental power to the electric motor, and start the engine. Another application is in renewable energy systems. Renewable energy systems, such as wind turbines and solar power plants, rely on efficient and reliable generators to convert energy into electricity. Brushless alternators are well suited for use in renewable energy systems due to their high efficiency, low maintenance requirements, and long lifespan. Another application of brushless alternators is in uninterruptible power supplies or UPS. Uninterruptible power supplies are used to provide backup power in the event of a power outage. Brushless alternators can be used in UPS systems to provide a reliable source of backup power. Brushless alternators are a versatile technology that is used in a wide range of applications. Their high efficiency, low maintenance requirements, and long lifespan make them an ideal choice for many different applications. As technology continues to advance, brushless alternators are expected to play an increasingly important role in the future of power generation and distribution. Finally, consider microgrids. Brushless alternators are also finding increasing applications in microgrids. Microgrids are localized energy grids that can operate independently or in conjunction with the main power grid. Brushless alternators can be used in microgrids to provide a reliable and efficient source of power.